Alright, now that we've taken a look at free body diagrams, let's take a look at calculating the net force acting on an object. Really simply, so example 3.1.2 says calculate the net force when you lift a book up with a force of 32 newtons and there's a force of gravity of 28 newtons. Okay, so if we think about our object, this 32 newtons that we are exerting is this lifting force that we are acting in this direction. So in terms of the forces that we've described so far, it is an applied force of 32 newtons in that up direction. Okay. We know because gravity acts down, this 28 newtons exerted by gravity is going to be the force that opposes this applied force. So our force of gravity acts 28 newtons in the down direction. Okay. Much like we did in kinematics, in dynamics we can define directions. Okay, so in terms of not having to carry that direction through, I'm going to say any force that acts up is positive. So F net simply just looks at, or net force looks at, the forces that are involved on the object. Okay, the two forces that are involved are the applied force plus that force of gravity. Okay, but this is where direction has to be taken into consideration. Because gravity acts down, we should plug it in as a negative force. The applied force acts up for us, right? So because the applied force acts up, we're plugging it in as a positive vector quantity in this case, okay? And that will solve, or allow us to solve, for the net force acting on our book. So the net force acting on our book is going to be this 32 newtons that I'm plugging in as a positive value, subtract this 28 newtons. So the net force that I get on our object is a positive 4 newtons. Okay, and remember what this positive tells me is because I have positive, that tells me the direction of our net force because we've defined it before. So when we're going and doing our therefore statement of what the net force acting on the object is, because it is still a vector quantity, we do need direction. So the net force acting on our object, let's take a look at our significant figures. 32 has 2, 28 also has 2. So we're rounding our answer to 2 significant figures, so the net force acting on the object is 4.0 newtons, and remember, because it's positive, the net force is in the up direction. Okay, so remember, forces are still vector quantities, so those directions really do have to be taken into account in order to solve for the total net force. If you simply just go and add the forces together here, you're going to get a net force of 60 newtons, right? Which is very, very different than you think of a net force of 4 newtons. And you're going to see why that's very different when we get into Newton's 3 laws. Okay, that's example 3.1.2. This is Wanny signing off, and may the force be with you.